Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the area for triangle practice questions. If you need any extra help on finding the area for triangle, if you go to corbettmaths.com/contents and scroll down to video number 49, there's a video tutorial there on how to find the area for triangle. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the answers to the practice questions, so let's get started. So question number 1, we've been given this triangle. It's a right angle triangle and it's got a base of 6 centimeters and a perpendicular height of 12 centimeters. And we've been asked to work out the area of the triangle. So the area of a triangle is given by the formula half the base times the height. So that means that we can half the base and then multiply by the height, or we could do the base times the height and then half it, or we could even half the height and then times the base. So as long as we're multiplying the base and the height and then halving it, we will find the area for the triangle. So to find the area for this triangle, we're going to do half the base, so half of the base, so half of 6 multiplied by 12. So half of 6 is 3, so that's going to be 3 times 12, and 3 times 12 is 36. So the answer is 36 centimeters squared. Now we could have done this question in a different way. We could have done 6 times 12, which is 72, and then half it to get 36. Alternatively, we could even half the height, so half of 12 is 6, and then do 6 times 6, which is 36, but they'll all give you the same area. Okay, question number 2. Okay, let's have a look at question number 2. So question number 2, we've been given a right angle triangle. It's got a base of 9 centimeters and a height of 8 centimeters, and we've been asked to work out the area of the triangle. So to find the area for the triangle, we do half the base times the height. So that means we could do half the base, which would be 4.5, and then multiply by 8, and that would give us the area for the triangle, but it's a non-calculator question, so I'll probably not use that approach. We could even half the height, which is 4, and then do 4 times 9, which would be 36, so that's another approach which would give us the answer. Alternatively, we could times the base and the height together, and then half it, and that's the approach I'm going to use in this question. So we're going to do half, and then we're going to do the base times the height, so that's 9 times 8, and 9 times 8 is 72, so we're going to do half of 72, and then half of 72 would be equal to 36, because half of 70 is 35, half of 2 is 1, add them together is 36. So the answer would be 36 centimeters squared. So there for that triangle is 36 centimeters squared. Okay, question number 3. So question number 3, it's a calculator question, and we've been given this right angle triangle, and this time we've got 3 lengths. So we've got the length of the base, which is 7.2 centimeters. We've got the height of the triangle, which is 5.4 centimeters, and we've got the length of the diagonal here of 9 centimeters. And we've been asked to work out the area of this triangle. So again, the area of the triangle is given by half the base times the height. So if we have a look, the base of the triangle is 7.2. The height, the perpendicular height, which means the height going from the base to the tallest point of the triangle, is 5.4 centimeters. And that means we won't actually be using the 9 centimeters here because it's just the length of the diagonal. We just need to do the base times the height and then half it, or half the base times the height. So we're going to do half the base times the height. And this question is a calculator question, so I'm just going to do 5.4 multiplied by 7.2, and then I'm going to half it. So let's see what we get. So 5.4 multiplied by 7.2 is equal to 38.8. So we're going to do a half of 38.8. And when we get to that, we get an answer of half of 38.8 is equal to 19.44. So 19.44 centimeters squared. So we multiplied the base by the height, and then we halved it to get 19.44 centimeters squared. We could have used a different approach. We could have halved the base, so that would be 3.6, and we could have done 3.6 times 5.4, and that would give us 19.44 as well. Alternatively, we could half the height, which is 2.7, and do 2.7 times 7.2, and that would also give you 19.44 centimeters squared. So all three approaches would work, but we wouldn't use the length of the diagonal because we're just using the base and the height to find the area of the triangle. So the answer is 19.44. Okay, let's have a look at question number 4. Okay, let's have a look at question number 4. So question number 4, we've been given this triangle. The triangle has got a base of 10 centimeters. The length of this diagonal is 8 centimeters, and it's got a height going from the base up to the tallest point of the triangle of 5 centimeters. So the area of a triangle is half the base times the height. So we need to find the base and the height of this triangle. So the base of the triangle is 10 centimeters. The height of the triangle from the base up to the tallest point is 5 centimeters. So we're going to do half the base times the height. The length of this diagonal we're not going to be using as part of this question. So we're going to do half the base. So we're going to do half of the base, so half of 10. And then we're going to multiply it by 5. And half of 10 is 5, so we're going to get 5 times 5. 5 times 5 is 25 centimeters squared. So the answer is 25 centimeters squared. Okay, let's have a look at question number 5. Okay, question number 5. We've been given this triangle. It's got a base of 24 millimeters and a height of 19 millimeters. And we've been asked to work out the area of the triangle and to include suitable units. So the area of a triangle is given by the formula half the base times the height. So we're going to do a half of the base times the height. So we could half the base, so half of 24, and then we can times by 19. So if we do half of 24, that's equal to 12, and then we're going to multiply that by 19. And that will give us the area of this triangle. So 12 times 19 is equal to 228. Now in terms of our units, we've got millimeters and millimeters. So our area is involving millimeters. It's going to be millimeters squared, or square millimeters. So the area of this triangle is 228 millimeters squared. Okay, let's have a look at our next question. Question number 6. So question number 6, we've been given this triangle. It's got a base of 16 centimeters and it's got a height, the distance between the base and the tallest point of the triangle, of 7 centimeters. And we've been asked to work out the area of the triangle. So the area of the triangle is given by the formula half the base times the height. And the base would be 16, so we can do half of 16, so half of 16, and then multiply that by the height 7. A half of 16 is equal to 8, so we can do 8 times 7, and 8 times 7 is equal to 56. So the area for this triangle will be 56 centimeters squared. And that's our answer, 56 centimeters squared. Okay, our next question. Question number 7. So question number 7, we've got this right angle triangle. We've got the base of the right angle triangle is 7 centimeters, and we've got the height of the triangle being 4 centimeters. And Jaden is working out the area of this triangle. And he says the area is 28 centimeters squared, as 7 times 4 is equal to 28. Explain why Jaden is incorrect. Now if we did 7 times 4, we would actually be working out the area of the rectangle. So this whole rectangle, we would be doing 7 times 4 to get the area of the rectangle. But for the triangle, remember, we need to half it. So we need to do the area of the triangle is equal to half the base times the height, and that will give us the area of the triangle. So the area of the triangle is half the base times the height. So we need to explain that Jaden at some point needs to half. So he needed to half this answer of 28 to get 14 centimeters squared. So let's explain that. So I've just explained that Jaden needs to divide by 2. So the answer is 14 centimeters squared. Okay, let's have a look at our next question. So question number 8. Okay, question number 8. A triangle has a base of 14 centimeters and it's got a perpendicular height of 9 centimeters. Find the area of the triangle. So we know that the area of a triangle is given by half the base times the height. So we need to do the base times the height and then half it, or half the base times the height, or half the height times the base. Any of those 3 approaches would work. Now this is an on-calculator question, so I'm going to actually half the base to begin with, because it's an even number. I can half 14 to get 7, and then that's going to make the calculation a bit easier. So I'm going to do a half of the base, half of 14, and then I'm going to multiply by 9. A half of 14 is 7, so 7 times 9, and 7 times 9 is 63. So the area of this triangle will be 63 centimeters squared. And that's it. Okay, let's have a look at question number 9. So in question number 9, we've been given this centimeter square grid, so each square is 1 centimeter by 1 centimeter, and that means it would have an area of 1 centimeter squared, or 1 square centimeter. And we've been asked to draw a triangle with an area of 10 centimeters squared. So that's a triangle that would have 10 squares inside of it. Now that means the area of a triangle is given by half the base times the height. So to find the area of the triangle, we do the base times the height, and then we half it to get our area. So if we take our area and double it, so 10 times 2, 10 times 2 is equal to 20. So that means that whenever we do the base times the height, it would have to be equal to 20. Because whenever we get our base times the height, times them together, we get 20. And then if we half it, we get the area of 10. So we need to find a triangle which will have a base and a height, which whenever we multiply their lengths, we get 20. So that could be 2 and 10, 4 and 5, 1 and 20. Could even include decimal numbers as well if you wanted to. I'm going to go for 4 and 5. I'm going to use a base of 4 centimeters and a height of 5 centimeters. So a base of 4 centimeters, 1, 2, 3, 4, and a height of 5 centimeters, 1, 2, 3, 4, 5. And then we'll just join those up. So the base of this triangle has got a length of 4 centimeters. The height of this triangle has got a height of 5 centimeters. And that means that this triangle would have an area of 10 centimeters squared, because 4 times 5 is 20 and half of 20 is 10. So that is a triangle with an area of 10 centimeters squared. So question number 10, we've been given a right angle triangle. It's got a base of y and a height of 6. And we're told the area of the triangle is 21 centimeters squared. And we've been asked to work out the length of the base y. So remember, to find the area of the triangle, we do the base times the height, and then we half it to get the area. So we have done this number, y, times 6, and then we've got that answer, and we've halved it, and that's given us 21. So if we take our 21 and double it, or times it by 2, that will tell us what the base times the height is. So 21 times 2 is equal to 42. So that means that the base times the height must have been 42, because whenever we halve it, we get 21. So we need to then take 42 and divide it by 6, and we can find out what y is. So if we do 42 divided by 6, that's equal to 7. So that means that the base of this triangle must have been 7 centimeters. And we can check our answer. 7 times 6 is equal to 42, and 42 halved is equal to 21 centimeters squared. So our answer is 7 centimeters. The length of the base is 7 centimeters. So we took the area, we doubled it to find what the base times the height was, and then we just divided that answer by the height to find the base, and that's it. Okay, let's have a look at our next question. Okay, question number 11. So question number 11 is quite similar to question number 10, where we've been given the area for the triangle, and this time we've been given the base is 35 centimeters, and we've been asked to work out x, the height of the triangle. So we know to find the area of a triangle, we do the base times the height, and then we half it, base times height, and then half it. So that means to find this area, we have done 35 times this number, and then divided by 2 to get the area. So if we take this area and double it, so multiply by 2, that would tell us what the base times the height is. So if we do 455 times 2, that would be equal to 910. And then that means that the base times the height would be equal to 910. So if we divide 910 by the base, we can find the height of the triangle. So 910 divided by 35 is equal to 26. So that means that the height of this triangle would be 26 centimeters. And that's it. So x is 26. And we can check our answer, because if we took our base times our height, so we do 35 times 26, that's equal to 910. And then if we divide by 2, that's equal to 455. So that's it. So let's have a look at question number 12. So question number 12 says, here's a triangular field. So this is a triangular field, and the length of the sides are 14 meters, 48 meters, and 50 meters. And we've been asked to work out the area of the field. So to get the area of a triangle, area is equal to half the base times the height. So we need to find the base and the height of this triangle. Now if we look at it, if 50 was the base, we wouldn't actually know the height of this triangle, because we don't know the distance from here up to the tallest point. But if we turn our heads and we look at it this way, so looking at it this way, so turn the page if you wanted to, then you've got a base of 14 meters and the height would be 48 meters. So that would be the base and that would be the height. So we've got a base of 14 meters and a height of 48 meters. And if we use those, we can find the area of the triangle. So sometimes we just need to rotate the triangle to find the base and the height. So to find the area of a triangle, we're going to do half the base times the height. This is a non-calculator question, so I'm going to half the base to begin with. I'm going to do half of 14, and then I'm going to multiply that by the height of the triangle, which is 48. So half of 14 is equal to 7, and then if we do 7 times 48, that will give us the area of the field. So this is a non-calculator question, so 48 multiplied by 7. So 7 times 8 is 56, put our 6 down, carry our 5. 7 times 4 is 28, plus 5 is 33. So the answer would be 336 square meters, or meters squared. And that's the area of the field. So sometimes if you've been given a triangle, you might need to just rotate it to find the base and the height. You could have rotated it the other way and looked at it this way and said, well, the base is 48 and the height is 14. So that would work also. But as long as you use the 14 and the 48 as the base and the height. And that's it. So our answer is 336 square meters, or meters squared. Okay, let's have a look at our next question. Question number 13. So question number 13 says, below is a right angle triangle. So we've got a right angle triangle, which has got a base of 5 centimeters, a height of 12 centimeters, and this diagonal of 13 centimeters. And we've got this rectangle, which has got a length of 10 centimeters and a width of x. And the area of the right angle triangle is equal to the area of the rectangle. So both shapes have got the same area. So if we work out the area of the triangle, then that will tell us the area of the rectangle, and then we can work out the width of the rectangle. So let's find the area of the triangle to begin with. So let's start with the triangle. So a triangle. The area of a triangle is equal to half the base times the height. So we need to do the base times the height and then half it. So I'm going to do a half of the base times the height. So the base is 5 and the height is 12. So if we do 5 times 12, that's 60. And we do a half of 60, that'll give us our area. And a half of 60 is 30 centimeters squared. So the area of this triangle is 30 centimeters squared. But we're told that the area of the triangle is equal to the area of the rectangle. And so that means that this rectangle has got an area of 30 centimeters squared as well. Now we know the length of the rectangle, so we can then just work out the width of the rectangle. So remember, the area of a rectangle is given by the length times the width. So we just do 10 times this number is equal to 30. We can probably realize already it's going to be 3 centimeters, but we can just take our area, 30, and divide it by 10, and that would tell us our width. And 30 divided by 10 is 3. So that means that x must be 3 centimeters. X equals 3 centimeters. Let's write that down. X is equal to 3 centimeters. So the answer would be 3 centimeters. Okay, let's have a look at question number 14. So in question number 14, we've been given this square grid, and it's a centimetre square grid, and we've been asked to draw an isosceles triangle with an area of 15 centimetres squared. So first of all, what is an isosceles triangle? Well, an isosceles triangle is a triangle where two sides are the same length. So whenever we draw it, I'm going to probably draw a triangle that whenever I draw the tallest point, it's above the middle of the base. And we've been also given the area of the triangle. The area of the triangle is 15 centimetres squared. So the area of a triangle is given by half the base times the height. So that means that we would do the base times the height and then half it to get the area. So if we take the area and double it, that will tell us what the base times the height was. So if we do 15 times 2, that's equal to 30. So we want to draw a triangle that whenever we times the base by the height, we're going to get 30. So I'm going to draw a base of 6 centimetres. So I'm going to draw a base of 6 centimetres. 1, 2, 3, 4, 5, 6. Because 6 times 5 is equal to 30. So that's my base of 6 centimetres. And now I'm going to want a height of 5 centimetres. But it's an isosceles triangle. So I'm going to go to the middle of my base and I'm going to go up 5 centimetres. 1, 2, 3, 4, 5. So that's got a height of 5 centimetres. And then if we join that point up to the left-hand side of the base and the top point to the right-hand side of the base, that will give us an isosceles triangle. It's got a base of 6 centimetres. It's got a height of 5 centimetres. So if we go up from the middle of the base up to the top, it's got a height of 5 centimetres. It's isosceles because it's got that line of symmetry down the middle, and we know that the left-hand side would have the same length as the right-hand side. And whenever we do 6 times 5, that's equal to 30. And then if we half it, we get an area of 15 centimetres squared. So that's it. And I've chosen a base of 6 centimetres and 5 centimetres because 6 times 5 is 30. I could have chosen 10 and 3 if you went 10 squares across. So let's just check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you could have done 10 squares across and gone up 3. 1, 2, 3. And that would have been an isosceles triangle. You could have done 5 and then in the middle, which would have been 2.5, you could have then gone up 6 squares and so on. But as long as your base times the height would be equal to 30, then that would be a triangle with an area of 15 centimetres squared. And then just it has to be isosceles. Okay, our next question, question B. Okay, part B. Part B says on this centimetre grid, draw a scalene triangle with an area of 10 centimetres squared. So again, the area of a triangle is given by half the base times the height. So if we take the area and double it, so if we do 10 multiplied by 2, that's equal to 20. So that means the base times height must have been 20, so that whenever we halved it, we get an answer of 10. So we need to draw a triangle that has a base and a height that whenever we multiply those lengths together, we get 20. So I'm going to choose 5 and 4. So I'm going to choose a base of 5 centimetres. 1, 2, 3, 4, 5. So we've drawn our base of 5 centimetres. Now we've been asked to draw a scalene triangle. So we don't want to draw an isosceles triangle. We don't want to draw an equilateral triangle. We want to draw a scalene triangle. So that's a triangle where all 3 lengths are different and all 3 angles are different sides as well. So I'm not going to go, well, the base is 5. I'm not going to go 1, 2, 3, 4 up and do that point because that would be an isosceles triangle. So I don't want to put my point there. I could put it here and that would make a scalene triangle. So I could join up here to here and then from here to here. And that would be a scalene triangle because all 3 lengths are different. Alternatively, we could even move the point slightly further out. We could go from here to here and from here to here, and that would work as well. And let's just put on our measurements. So we've got our base of 5 centimetres. So 1, 2, 3, 4, 5. We've got a height of 4 centimetres. 4 centimetres, and that is a scalene triangle because all 3 lengths are different, and the area of the triangle is 10 centimetres squared because whenever we do 5 times 4, that's 20, and half of 20 is 10. So the area of that triangle is 10 centimetres squared. Okay, and that's it. Okay, question number 15. So question number 15 says the diagram below shows a right angle triangle and a square, and the area of the square is twice the area of the triangle. Calculate the length of each side of the square. So here we've got a triangle and we're told that the area of the square is twice the area of the triangle. So let's find the area of the triangle. So the area is equal to half the base times the height. That's a non-calculator question, so I'm going to half the base, so half of 16, and then I'm going to get that answer and times it by 4. A half of 16 is 8, so we've got 8 times 4, and 8 times 4 is equal to 32 centimetres squared. So the area of the triangle is 32 centimetres squared. Now the area of the square is twice the area of the rectangle, so that means that this square has got an area of 64 centimetres squared, double the area of the triangle. Now we've been asked to calculate the length of each side of the square. Now 64 is a nice number, it's a square number. We know that 8 times 8 would be equal to 64. So the length of each side of the square would be 8 centimetres, and that's it. So the answer would be 8 centimetres. And let's just recap that question. So we were given a right angle triangle and a square. We were told the area of the square was twice the area of the triangle. So we found the area of the triangle by doing half the base times the height. So we done 8 times 4 is 32 centimetres squared. The area for the square was twice that, or double that, so that means the area of the square was 64 centimeters squared. We then found the square root of 64, and the square root of 64 is equal to 8, so that means that the side length is 8 centimeters, because to find the area of the square we do the length times the width, and that's the same number, so the square root of 64 is 8, so it would be 8 centimeters and 8 centimeters, so the side length is 8 centimeters. Okay, question number 16. So question number 16, we're told that below is a sketch of a triangle and it's not drawn to scale. So this is a sketch of a triangle and it's got a base of 10 centimeters. The angle on the left hand side is 45 degrees and the angle on the right hand side is 60 degrees. And we've been asked to draw an accurate drawing of the triangle below. So in this space below we need to draw that triangle. So let's draw that. So we've been asked to draw this triangle, so our first step is to draw a 10 centimeter line, and then we're going to do our two angles. So let's start off by drawing a 10 centimeter line. So get a ruler and pencil and draw a 10 centimeter line on the page. So draw that accurately, so that would be 10 centimeters, and use your ruler and pencil to do that. Now we're going to draw our angles. So our first angle is 45 degrees. So let's get our protractor and let's put it on the line like so. And you'll notice here that we have the 0 on the line and the cross of the protractor is on the left hand side of the line. And we want to measure a 45 degree angle. So because the 0 is on the inside of the protractor, we're going to go round. So we're going to go 10, 20, 30, 40. And then there's 50, so we're going to go around in our ones here, 41, 42, 43, 44, 45. And you'll see it's marked in the middle with a slightly longer line, so it's 45 degrees. And we'll put a dot there. Then we'll just move our protractor down and out the way for a moment. So now I would get my ruler and pencil and I would draw a line that goes from the left hand side of the line through that point like so. Okay, now as you can see I've drawn it slightly longer. That doesn't matter as long as this angle is 45 degrees, which it is. Okay, so we've done the angle on the left hand side of the triangle. We now need to do the 60 degree angle on the right hand side of the triangle. So let's get our protractor. So we're now going to put our protractor, so the cross of the protractor is on the right hand side of the line, on the end of the right hand side of the line there. And then you can see we've got our 0 and it's on the outside of the protractor. So we're going to go around to 60 degrees. So 10, 20, 30, 40, 50, 60 and put a dot. So that is a 60 degree angle. So let's move our protractor and we're going to get our ruler and pencil. And we're going to draw a line going from the right hand side through that point and carry on until you reach the other line. So then it would look something like that. Now I've gone slightly further. That doesn't matter, okay? And we're just going to mark in 60 degrees. And that's it. That's my triangle. It's got a base of 10 centimeters. The angle on the left-hand side is 45 degrees. The angle on the right-hand side is 60 degrees. And it meets at the point at the top here. Now, we do have those extra bits of lines. They're called construction lines. I tend to just leave them on, but if you want to rub them out, you can, but just be really, really careful. Okay, part B. Part B says calculate the area of the triangle. So we're going to now look at our triangle, and the area of the triangle is given by a half the base times the height. So we know the base of the triangle is 10 centimeters, so it's going to be half of 10, but we need to find the height of the triangle. So we're going to need to measure from the tallest point of the triangle straight down to the base of the triangle, like so. So you're going to measure that distance with your ruler. And whenever you measure that distance on your page, I've got an answer of 6.3 centimeters. Your answer should be approximately the same as that, so it should be roughly 6.3 centimeters. So we're going to do half the base times the height. So let's do that. So the area of the triangle is equal to half the base times the height. And this is an on-calculator question, so I'm going to do half of, and I'm going to do 10 times 6.3 to begin with. So I'm going to do the base times the height, and then I'm going to divide by 2. So I'm going to do 10 times 6.3, that's equal to 63, so half of 63, and a half of 63 would be equal to, well, half of 60 is 30, and a half of 3 is 1.5, so my answer would be 31.5 centimeters squared, and that's the area of the triangle. Okay, let's have a look at question number 17. So question number 17 says, the diagram below shows a garden. So we've got this garden, it's got a total length of 12 meters and a total width of 8 meters, and there's this triangular region in the middle. And if we scroll down, we're told some information. The garden has a triangular vegetable patch, so this is a vegetable patch, and the rest of the garden is grass. So all this green area is grass, and this brown or orange area region is a vegetable patch. And we've been asked to calculate the area of the garden that is grass. So we want to find out the green area. So to find that, what we're going to do is we're going to find the total area of the garden to begin with. So we're going to find the area of the rectangle. We're then going to find the area of the triangle and take it away. And what's left will be the area of the grass. So let's find the area of the whole garden. So whole garden. So the area of the whole garden, well, it's a rectangle, so we're going to do the length times the width. So we're going to do 12 times 8. And 12 times 8 is 96 meters squared, or square meters. So the area of the garden is 96 square meters, the whole garden. Now let's look at the vegetable patch. So the veg patch, So it's a triangle, so we're going to do half the base times the height, so half the base times the height. Now it's an uncalculated question, we've got a base of 5, so I'm going to do 5 times 4 and then half it, so half of 5 times 4. 5 times 4 is 20, so we're going to do half of 20, and half of 20 is 10. So the area of this vegetable patch is 10 meters squared, or 10 square meters. And the question asks us to work out the area of the garden that is grass. So the area of the whole garden is 96 meters squared. The area of the vegetable patch is 10 meters squared. So if we do 96 take away 10, that would tell us the area of the garden that is grass, the green area. And that is 86 meters squared. So the area of grass is 86 square meters, or 86 meters squared. Let's write that down. Okay, question number 18. So in question number 18, we've been given this logo and we're told it consists of a rectangle and an isosceles triangle, and we've been asked to calculate the area of the logo. So let's divide the logo into two. Let's split it into our rectangle and our isosceles triangle. And we want to find its total area, so that means we're going to want to find the area of the triangle and we're going to want to find the area of the rectangle. So let's start off with the rectangle. So the area for a rectangle is given by area is equal to length times the width. The length of the rectangle is 20 and the width is 6, so we're going to do 20 multiplied by 6. And 20 times 6, well, 2 times 6 is 12, so 20 times 6 would be 120 centimeters squared. So the area of this region, the rectangular region here, will be 120 centimeters squared. Now we've got the triangle at the top of the logo, so let's find the area of the triangle. So the triangle. So we need to find the base of the triangle and the height of the triangle. Well, the base of the triangle is going to be 6 centimeters because obviously the opposite sides of a rectangle have got the same length. So this is going to be 6 centimeters. So the base of the triangle is 6 and the height of the triangle is 5. So we're going to do half the base times the height to get the area of the triangle. So half the base, well, half of 6 is 3, and then 3 times 5 is equal to our area. So half the base times the height, 3 times 5 is equal to 15 centimeters squared. So the area of this triangle is 15 centimeters squared. Now I've been asked to find the area of the whole logo, so we're going to add together 120 and 15. So 120 plus 15 gives us the area of the whole logo, which is 135 centimeters squared. And that's it. Okay, let's have a look at question number 19. So question number 19 says the diagram below shows a farmer's field. So we've got this field and a farmer wants to plant a new crop. So he wants to plant a new crop and each sack of seed covers 30 meters squared, or 30 square meters. So each sack of seed, whenever he goes in the shop and buys a sack of seed, it'll cover 30 square meters of this field. And each sack costs £6. Work out the total cost to buy enough seed to cover the field. So we need to work out the area of the field. So let's find the area of the shape to begin with. Now if we look at it, we can split it into a rectangle and a triangle. We've got this rectangle here and we've got this triangle here. So let's find the area of the rectangle to begin with. So the area of the rectangle, so here, area is equal to length times width. So the length is equal to 80, the width is equal to 30. 80 times 30 would give us the area of this field. 80 times 30, it's a calculator question, so this is quite nice, so you can just type that in. Or you can do 8 times 3 is 24 and put on our 2 zeros. So the area of this part of the field, this rectangular part, would be 2,400 square meters, or meters squared. Now we need to find the area of this triangle. We need to find the area of this triangle. So to find the area of the triangle, we need to know its base and its height. So if we have a look here, we've got the length of the whole base here being 100 meters and the length of the top being 80. So if this part's 80 and this whole length is 100, that means this extra bit must be 20 meters. So 20 meters would go from here to here. So that is the base of the triangle. Now we need to find the height of the triangle. Well, the whole height is equal to 30 meters and this part is equal to 10. Well, 30 take away 10 leaves us the height of the triangle, which would be 20 meters. So this triangle has got a base of 20 and a height of 20. So we then just need to work out the area of this part and then add them together to get the area of the whole field. So for the triangle, let's write that down, triangle. Area is equal to half the base times the height. So base times height, well, the base is 20, the height is 20, so let's do half of 20 times 20. It's a calculator question, but we shouldn't need it here actually. 20 times 20 is 400, so we're going to do half of 400, and a half of 400 is 200 meters squared. So the area of this triangle is 200 meters squared. So the area of the whole field would be 200 plus 2,400, and that would give us the area of the whole field. So the whole field, 200 plus 2,400 is equal to 2,600 meters squared, or square meters. So that's the area of the whole field. Now, We're told that each sack of seed covers 30 square meters. So he buys these sacks of seeds and each one of them covers 30 square meters. So we need to see how many sacks of seed he needs to buy. So we need to divide 2,600 by 30 to see how many sacks he needs. So 2,600 divided by 30 will tell us how many sacks of seeds he needs. So 2,600 divided by 30 is equal to 86.666 and so on. So 86.6 reoccurring. So to cover the field exactly, he's going to need 86.66666 sacks. But if you go into a shop and you go to buy the 80 sacks, it's unlikely you can go in and go, oh, can I have 86 of them plus 0.66666 of another bag? You're going to have to buy 87 bags, 87 sacks. So there's going to be 87 sacks needed. So he needs 87 sacks, and each sack costs £6. So he's going to have to buy 87 sacks that cost £6 each. If we do 87 times 6, that would tell us the total cost to buy enough seed to cover the field with a little bit extra. So 87 multiplied by 6 is equal to £522. So it's going to cost him £522 to buy the 87 sacks that he needs to have enough seed to cover the field. Okay, let's have a look at our next question. Okay, question number 20. So question number 20 says, a council is designing a dog park that would be in a rectangular field. So we've got this rectangular field. We're told that the length of the field is twice the width of the field. Well, we know the width of the field. The width of the field is 70. So if we double 70, that's 140. That means the length of the whole field would be 140 meters because the length of the field is twice the width of the field. The field will be divided into two sections. So the field, this rectangular field, will be divided into two sections. One for the large dogs, so the large dogs can go in here and play in this dog park, and the small dogs can go and play in here. So this is the region for the small dogs. And we've been asked to work out the difference in area between the section for the large dog and the section for the small dogs. So in other words, we need to find the area of the section for the large dogs, we need to find the area for the section for the small dogs, and then take them away to find the difference in area. Okay, so if we have a look at our diagram, we can see that we've got this rectangular field. It's got a length of 140 meters, a width of 70 meters. We've then got this region for the small dogs, and that's a triangle, and we can find the area for triangle. We've got this region for the large dogs. Now it is a trapezium. Now you can find the area for trapezium if you watch the Corbettmaths video on finding the area for trapezium. I'm going to do this question as if we haven't seen that yet, and I'm going to do this question based on just the knowledge of finding the area for triangle and a rectangle. But if you know how to find the area for the trapezium using the formula half a plus b times the height, then that can then be useful to find the area of the region for the large dogs, and you're welcome to use that if you wish. Okay, so let's do this question as if we only know the area for a triangle and a rectangle. So let's find the area of the region for the small dogs. So the height of that region, the height of that triangle is 70 meters. Let's find the base of that. So the length of the whole field is 140 meters. If we take away 60, we can then find the length of the base of that triangle. So if we do 140 take away 60, that's equal to 80. So that means that this length, this distance is 80 meters. So we now know the base of the triangle and the height of the triangle, so we can work out the area of this triangle, the region for the small dogs. So let's do that to begin with. So the area for triangle, area is equal to half the base times the height. It's a calculator question, so I'm just going to do 80 times 70 and then divide by 2. So a half of 80 times 70. 80 times 70 is equal to 5,600, and then if we divide that by 2, that's 2,800 meters squared. So the area of this region for the small dogs is equal to 2,800 square meters. That's how much space the small dogs have. So we now need to find the area of the region for the large dogs. So we know the area of the region for the small dogs, and we can find the area of the whole rectangular field by doing 140 multiplied by 70. That would give us the area of the whole field. And 140 multiplied by 70 is equal to 9,800 square meters or meters squared. So we've got the area of the whole field. We've got the area of the region for the small dogs, which was 2,800, so this is 2,800 square meters or meters squared. If the whole thing adds up to 9,800 meters squared, that means that the large dogs would have to be taking 2,800 away from 9,800 would leave us with 7,000 meters squared. So that means that the area for the large dog is 7,000 meters squared or square meters. And we've been asking this question to work out the difference in area between the section for the large dogs and the section for the small dogs. So we want to work out the difference in this area. So we just need to take them away, and that's our answer. So 7,000 take away 2,800 would be equal to 4,200 meters squared. So the difference in area is 4,200 meters squared or square meters. So that's it, that's our answer. Okay, and let's have a look at our last question, question number 21. So we're told in question number 21, A, B, C, D and W, X, Y, Z are squares. So this whole shape is a square and this shape is a square. And we're asked to calculate the area of the shaded square W, X, Y, Z. Now if you have a look at A, B, C, D, you can see that's a square. But it has 1, 2, 3, 4 triangles and then the area of the region that we want to find. So if we find the area of the whole square, A, B, C, D, by doing 10 times 10 to get the area of the whole square, and then we find the area of the 4 triangles, and they are identical triangles, so if we find the area of those triangles, then we can take them away to see what's left for the area of the shaded square, W, X, Y, Z. So let's do that. So the area of the whole square, A, B, C, D, would be equal to the length times the width, which is 10 times 10. So if we do 10 times 10, that's equal to 100 centimeters squared. So that's the area of A, B, C, D. Now we want to find the area of the triangles. So let's focus on triangle 1 to begin with, okay? So that is a right angle triangle, because it's a square, it's a right angle. We've got, if we turn our head upside down, if we look at it the other way around, we've got a base of 2 centimeters and a height of 8 centimeters. So the area of the area of triangle 1 would be equal to half the base times the height. So it's going to be half of the base, which is 2, times the height, which is 8. 2 times 8 is 16, and a half of 16 will be equal to 8 centimeters squared. So the area of this triangle is 8 centimeters squared. Now because this is a square, that means that all of the 4 triangles will be identical, because obviously the distance, if that's 8 and that's 8, that's going to be 2 centimeters. That's going to be 8 centimeters. That's going to be 2 centimeters. That's going to be 8 centimeters, and that's going to be 2 centimeters. So these 4 triangles have all got the same area, so they're all going to be 8 centimeters squared, 8 centimeters squared, 8 centimeters squared. So if we want to find the area of this shaded square, W, X, Y, Z in the middle, all we need to do is take our 4 lots of 8 away from our 100, and that'll tell us the area of this square. So if we do 4 times 8, that's equal to 32. And then if we do 100, take away 32, that's equal to 68. So the area of this square in the middle would be 68 centimeters squared. And if we check it, we've got 4 triangles. The area of each triangle is 8 centimeters squared. 4 lots of 8 is 32, plus 68 is equal to 100. And the area of the whole square was 10 times 10, which is 100. So the area of that square is 68 centimeters squared. And that's it. These have been the video solutions to the area of a triangle practice questions. If you need any extra help on finding the area of a triangle, go to video 49 in Corbettmaths or scan this QR code. But that's it. So I really hope you found this video useful. If you have found it useful, please like it, please subscribe to the YouTube channel, and thanks so much. Cheers. Bye.